Welcome to ACT Math Prep. This is Session 4, Statistics and Probability. I'm your instructor, Sarah Gale. The ACT Math Test contains several topics: number and quantity, algebra, functions, geometry, trigonometry, statistics, and probability. For this course, I have divided those into 4 class sessions: number and quantity, algebra and functions, geometry and trigonometry, and today's session, statistics and probability. In statistics and probability, the subjects that you're expected to be able to know are: describe the center and spread of distributions, apply and analyze data collection methods, understand and model relationships in bivariate data, calculate probabilities including the related sample spaces. And it's important when you're taking a test such as the ACT, any standardized test or a classroom test, to think metacognitively. That means to understand how you think. The way we go about this process is to assess the task, evaluate your own strengths and weaknesses, make a plan for how you're going to approach the test, and then when you're taking the test, apply the strategies you came up with, and always monitor your performance as you work so that you can reflect on how it's going and adjust if you need to. Make sure that you've gone into the Google Classroom and clicked on that classwork tab and downloaded and printed out the statistics and probability worksheet. You can pause this video and do that now if you haven't got it ready. And we will now work through the statistics and probability worksheet together. Let's begin the practice problems now. To test a new medicine, each of the 300 volunteers was assigned a distinct number from 1 to 300. Next, a calculator was used to simulate drawing 150 balls from among 300 congruent balls. The balls were numbered the same way as the volunteers, so that 150 volunteers to receive the new medication would be chosen without bias. The other volunteers received a placebo. Weeks later, the two groups were compared. Which of the following phrases best describes the company's testing? This is one for you to try on your own. You have 1 minute. Begin now. And that's 1 minute. The correct answer is B, randomized experiment. So when we're looking on this, you have randomized versus non-randomized as the first choices. So the difference between randomized and non-randomized. Non-randomized is if people are assigned to the groups specifically. Randomized is when what we have here, they're randomly assigned, so balls were drawn, and that made it random. Next, you have census, experiment, or survey. So you have a population of people. If you hand out questions for all of them to answer, the entire population, that's a census. If you hand out questions for just a portion or a sample of the population, that's a sample survey. And if you make 2 groups and compare them, do one thing to one group and something else to another group and compare them, that is an experiment. So because in this one we have 2 groups where one receives medication, the other receives a placebo, and they're compared, That means it's an experiment. Choice B. Number 2. For 20 quiz scores in a typing class, the table below gives the frequency of the scores in each score interval. Which score interval contains the median of the scores? So this is an example of one of our central tendency questions. There are 3 central tendency measures. There's mean, median, and mode. Okay, now there's a memory device that I made up for my students to learn which is which, mean, median, and mode, because they sound similar and it's easy to get confused, okay? So the definitions of these are that the mean is the average, the same as the average. To calculate an average, you add all the numbers together and then divide by how many numbers you have. The median is the middle number. That's the number that is physically in the middle of the data set if you not put them all in order. It's very important for the median that the numbers be put in order, and then you find the physical middle number. And then the mode is the most. It's the number that occurs most frequently. So in this one, you have to have some number that's been repeated, right? If you don't have any repeated numbers, you're not going to have a mode in that data set. The way that I taught my students to remember this is I actually made up a song. It's to the tune of 3 Blind Mice. Okay, so here it goes. Mean, median, mode. Mean, median, mode. Mode is the most. Median is the middle. The mean is the average, and so you add. Divide by how many numbers you had. Mean, median, mode. So that's the song. It's beautiful. I know. So that's how we remember this. Mode, most, median, middle, and the mean is the average. It's a mean equation. That one's the hardest to calculate, so it's mean, right? So in this one, we're looking for the median of the scores. Remember, that is the one that is physically in the middle after we have put them in order. So we look here and we see that our score intervals, they're in numerical order. So what we can do is take our frequency over here and make tally marks, okay? So 96 to 100 has 3, 91 to 95 has 1, 86 to 90 has 3, 81 to 85 has 4, and 76 to 80 has 9. All right, so to find the one in the middle, we can just cross off the first and the last, second to last, right? 3, 4, 5, 6, 7, 8, 9, and 10. And here it is right there, our one in the middle. It is in 81 to 85. Okay. Next problem, the table below gives experimental data values for variables x and y. So this is one of our bivariate data examples. Bivariate, bi means 2, and then variate, variable, it's 2 variable data, okay? It's not scary, bivariate, 2 variable, x and y. Theory predicts that y varies directly with x. Based on the experimental data, which of the following values is closest to the constant of variation? Note, the variable y varies directly with the variable x, provided that y equals kx for some non-zero constant k called the constant of variation. So if you look at this, y equals kx, that's just a linear equation there, right? Just like y equals mx plus b, but we don't have a b. So that tells me that k is just the slope. And it's true, direct variation, if you see direct variation, right, then you should automatically think it's just like a linear equation. And the constant of variation is the same thing as the slope. So all we're going to do is calculate the slope. So to calculate the slope, slope is the change in y values over the change in x values. Okay, that little triangle is a delta, it means change. Okay, so we can pick 2 y values here. and subtract them to find the change. And then for the bottom, you pick the corresponding x values and subtract them to find the change in x. So our change in y over our change in x. Okay, we can divide those numbers in the calculator and we get 0.0495. Okay, and of course the question asks which one is closest to, so that would be B. Okay, next one. A finite arithmetic sequence has 7 terms and the first term is 3/4. What is the difference between the mean and the median of the 7 terms? Okay, so when I'm given a sort of general information like this, it's generalized information, what I like to do is try to make a specific example and see what that looks like. Okay, so 7 terms. An arithmetic sequence is where you add the same amount between each term. All the terms are equally spaced, right? So if our first term is 3/4, and we're making an arithmetic sequence, so we can just pick a number that you could add between each one. So maybe let's add 1 in between every term. That's how you make an arithmetic sequence. So 3/4 plus 1, 1 3/4, plus 1, plus 1, right? So we're just adding the same amount to generate this arithmetic sequence. Okay, so now we have an arithmetic sequence with 7 terms and the first term is 3/4. Okay, so we want to know what is the difference between the mean and the median. So remember that our median is the one that is physically in the middle when the numbers are in order. These are in order, and the number in the middle here is 3 3/4. That's our median. Okay. So now what is the mean of this data set? So remember, the mean is the average, and so you divide by how many numbers you had, right? And we don't have to keep these, we can type it in the calculator. We can put them all as decimals. 3/4 is 0.75, just like 3/4 in money would be 75 cents. That's an easy decimal to know, right? So if we add these all up, and then divide by how many numbers we had, which is 7. There's 7 terms, right? So you add up the whole top and divide by 7, and you end up getting 3.75. You get 3 3/4. The median and the mean are the same. There's 0 difference between them. And the reason why that happens is because it's an arithmetic sequence. You're adding the same number to each term, and that means the terms are perfectly evenly spaced apart. If your terms are perfectly and evenly spaced, then the median and the mean are going to be the same number. Next one. The scatter plot in the standard XY coordinate plane below contains data points showing a strong linear correlation between the variables x and y. Mia drew the line shown to model the data. One of the following equations represents Mia's line. Which one? So here's the next one to try on your own. Okay, look at that line of best fit and choose the equation. You have 1 minute. Go ahead. And that is 1 minute. And the correct answer is B. Okay, so let's take a look at this. what you have in your answer choices are 5 linear equations, and they're in y equals mx plus b form. So that means you have m, or the slope, and you have b, which is the y-intercept. So if we look at this line and figure out the slope and the y-intercept, we'll be able to tell which equation it is. So the y-intercept, where it's hitting the y-axis, is up there at 10. So we know our equation ends with a plus 10, okay? That eliminates A and E. Now all we need to do is find the slope. Okay, so if I look at the next spot where the graph crosses right on a line, it's right there, okay? And so to do that, we go down to 7 and then over here and look down at the x-axis, that's over to 1. So we went from 10 to 7, that's a change of 3. And then we went over from 0 to 1, right? So 10 minus 7 is 3. 0 minus 1 is a negative 1. This is a slope of negative 3. And that's choice B. Okay, next problem. The median of a set of data containing 9 items was found. 4 data items were added to the set. 2 of these items were greater than the original median, and the other 2 items were less than the original median. Which of the following statements must be true about the median of the new data set? All right, so again, we've been given a theoretical data set. So let's make an actual data set that meets the qualifications and take a look at it, okay? So we have 9 items, right? And then we're gonna figure out the median. So let's just write these in. Remember, when you find the median, your data items have to be in order. So let's just write items in order, right? Okay, so there's 9 items. Now we find the median, the number that's physically in the middle. So you can see that there's 4 numbers to the left of that, 4 numbers to the right. That's the median. Okay, now we're going to add on 2 items. And 2 are greater than the original median. That means they're going to go over here. 2 are less than the original median, which means they go over here. Okay, so what about the new median? Well, if you added 2 things up here and you added 2 things down there, your median that was original is still in the middle, right? That's still physically right in the middle, so it's the same as the original median. Okay, next one. The sign of A is positive. The sign of B is negative if it can be determined what is the sign of the mean of A and B. So again, we're going to take our theoretical problem and try out actual things. So first, what is the mean? Remember, the mean is the average, and so you divide by how many numbers you had. That's just like the song, right? The song is useful. Okay, so that's the average. Can we tell if the average is going to be positive or negative, or choice C, both positive and negative, or D, neither positive nor negative? All right, so let's try this out. So if we pick numbers, we know that A is a positive number and B is a negative number. So let's just pick some random values. So if we chose positive 5 for A and negative 3 for B, 5 plus a negative 3 is 2. I just got a positive answer for my mean. But is it always positive? Can we think of 2 numbers for A and B that would make it negative? So what if A was 3 and B was negative 5? Then we'd get a negative 1. Okay, so it's not always positive. It's not always negative. Now don't get confused on this one. Both positive and negative. You get a single answer for a mean. Right? When you get a mean, it only has one single answer. There are some things that can have 2 answers, right? Like an absolute value. Okay, if you have something like this, Absolute value means you make it positive, so x could be either positive or negative 3 in this case, because putting positive 3 in for x gives you an absolute value of 3. Putting negative 3 in for x gives you an absolute value of 3. So this is an example, but in this case you only get one answer, so there's no way you can have both positive and negative. Neither positive nor negative, that would be if the answer was always 0. And you can see we didn't get 0 answers, so it's not that one. So it cannot be determined from the given information. Okay, next problem. We have another example where you have some data and a graph to look at, and you're supposed to use it to answer multiple questions. Okay, so here it says, a survey in a study skills class asked the 20 students enrolled in the class how many hours, rounded to the nearest hour, they had spent studying on the previous evening. The 20 responses are summarized by the histogram below. So take a look at that histogram. You can see hours across the bottom and number of students going up the y-axis. So, for example, if you look at 0 hours, you can see that there are 2 students who answered that they had studied 0 hours, right? All right, so the first question, what fraction of the students responded that they had spent less than 3 hours studying? This is one to try on your own. Remember from the previous lesson what we talked about with less than and what that means. All right, begin now. And that's 1 minute. And hopefully you were able to get answer D, 13 out of 20. So let's take a look at this. You remember from a previous session that the words less than and greater than, if you see those, they mean that the number is not included. At least and at most mean that the number is included. So here we have less than 3. That means the 3 is not included. That means what we're looking at is 2 hours, 1 hour, and 0 hours. All right, so we have in here that 6 students studied for 2 hours, 5 studied for 1, and 2 studied for 0 hours, and there were 20 students total. Right, so 6 plus 5 plus 2 is 13 out of 20, choice D. All right, same data. The teacher decides to show the data in a circle graph. What should be the measure of the central angle of the sector for 3 hours? So here we have a question that is combining statistics with the geometry. So remember back to our geometry that the central angle in a circle is proportional to this entire circle, right? So the entire circle, there are 20 students total, and the entire circle has 360 degrees, right? So we want the sector for 3 hours. That's this one right here, and we can see that there's 4 students in this little sector. So 4 students in this sector, what are the degrees for it? Okay, so we're going to cross multiply 20 times x and 360 times 4, which is 1440. Divide by 20, and we get that x equals 72 degrees. All right. And last problem using this data set. To the nearest tenth of an hour, what is the average numbers of hours for the 20 survey responses? So remember, the average, and so you add, divide by how many numbers you had, right? So what we have here, we're adding up number of hours, right? So you have 2 students who answered 0 hours, and 5 students who answered 1 hour, and we have 6 students who answered 2 hours, and we have 4 students who answered 3. I'm going to run out of room. 2 students who answered 4, and 1 student who answered 5. They must have AP classes, right? And we divide by how many we have. That's 20 students total. If you add that all up, you end up getting 42 out of 20. Our answer choices are in the form of decimals, so we can put that in our calculator and divide it and get 2.1. Okay. Next problem, a bivariate data set of observed values along with a line of best fit for the data set are shown in the standard XY coordinate plane below. The set of 4 residuals for the model is given by y sub I minus y of x sub I for I equals 1, 2, 3, 4, where y1 is the observed y value corresponding to the input x1 and xi y of x sub I is on the line of best fit. What is the absolute value of the largest residual for this model? Don't be scared by this problem, okay? So let's make a little picture for you here. If you have data points and you create a line of best fit to go through them, like this, the residual is the difference vertically, the distance vertically from any given point and that line of best fit, right? So points that are further away are going to have a larger residual, and points that are really close are going to have a smaller residual, right? Calculating the residuals can give us an idea of how accurate our line of best fit is, right? You want those residuals to be pretty small so that your line of best fit matches really well, all right? So that's just residuals, and you can figure out the length of a residual. Because it's a vertical line, all you have to do is look on the y-axis, right? If you take the y value here and subtract it from the y value of the actual point, then you have calculated your residual, and that's what it's telling you right here. Y sub I minus y of x sub I, right? This one is your y sub I, and the actual point on the line is your y of x sub I, okay? That's all it's saying is you take the difference in the y values. All right, so let's look at our picture over here. We want the absolute value of the largest residual. So remember, the residual is going to be larger if the dot is further away. So look at those dots. Which one is furthest away from the line? It's this one right here. The other 3 are touching the line. All right, what is the y value of that point? It's 135. And over here we have the equation of the line. Okay, so we have our point 32, 135. That has a y value of 135. And then we have our equation here. So to find out the y value of the actual line, we can plug this 32 into the equation of the line. That's what y of x sub 1 is saying. You plug the x value for your point into the equation of the line. Okay? So we get this 1.1 times 32. You can type that in a calculator. And then add to the 93, and you get 128.2. So the difference in our y's is 135 minus 128.2. Okay, so you subtract that, and you get 6.8, and then they want the absolute value of that, which is just 6.8. The reason why they ask for the absolute value is because sometimes the residual can be negative if the dot is down below the line, right? but a residual is like a distance. And we want that to be positive, and that's why they ask for absolute value. Okay, next one. The scores given below were earned by 10 students on a recent biology test. What is the median score? All right, so this is one to do on your own. And go ahead. And that's 1 minute. Hopefully you were able to answer that it was 87. So let's take a look at this one. Remember, the median is the physical middle score when the scores are in order. So the first thing you have to do is write these in order. Okay? So 71, 77, 78, 80, 86, 88, 88 again, and then 94, 94, 94. Okay, now we're going to find the one in the middle. So we'll cross off 1, 2, 3, 4, and here we have 2 that end up in the middle. So you have to actually go in the middle of the ones in the middle in order to find the actual median here. Okay, because it's easy to see what number is in the middle of 86 and 88. We can just figure it out. But if you had numbers that were far apart and you couldn't tell, like, you know, if this one was like 7 and this number was like 15 or something, the way you'd find the median then is to find the average of the 2 numbers in the middle. Okay? All right, next one. Set A and set B each consist of 5 distinct numbers. The 2 sets contain identical numbers with the exception of the number with the least value in each set. The number with the least value in set B is greater than the number with the least value in set A. The value of which of the following measures must be greater for set B than for set A? So, again, we have something theoretical, and we want to make actual sets that we can look at and compare. So, let's create set A and set B. And we know that they each have 5 terms. We know that the 5 terms are distinct. That means there's going to be no repeats. Okay? And we know that they contain identical numbers except for the smallest number in each set. And we know that the smallest number in set B is bigger than the smallest number in set A. So let's say if the smallest number in set B was 2, then the smallest number in set A could be 1. That way B is bigger. And then the rest of them are identical. Okay, and distinct, no repeats. So there we go. We have now made 2 sets that meet the qualifications. Now let's look. They're asking about mean, median, and mode. So again, median, the term in the middle. So these both have the same mode, right? So their mode is not going to be greater. We're looking for what must be greater. The mode is the same. So any question that includes mode, we can, or the median, we can cross out mode. Sorry. Okay, any question that includes median, we can cross out. Mode, we can also cross out because it's distinct. There's no repeats. No repeats means no mode. So we can get rid of all those choices. And that means it's the mean. Okay? The median is the same. There's no mode because they're distinct. The only one it must be is the mean. And you can see that that's true. When you do the mean, you add up all the numbers, right? 1 plus 3 plus 4 plus 5 plus 6, when you add that up, you get 19. And when you add up 2 plus 3 plus 4 plus 5 plus 6, you get 20, right? Divide by 5 for how many numbers we have, right? You get 3.8 and 4. The mean is bigger. And that's because having that first number be bigger makes the whole sum bigger. Next one. A bag contains 10 pieces of flavored candy, 4 lemon, 3 strawberry, 2 grape, and 1 cherry. 1 piece of candy will be randomly picked from the bag. What is the probability that the candy picked is not grape flavored? Here's one for you to try. Go ahead. 1 minute. And that's 1 minute. Hopefully you were able to answer that the answer is E, 4/5. So let's look at this. If you're doing not grape flavored, that means it's everything but grape, right? That means you have lemon, strawberry, and cherry out of the total, which is 10 pieces of candy. So 4 plus 3 plus 1 is 8. And 8 out of 10, the fraction can be reduced to 4/5. They're both divisible by 2. Okay, next question. At a local post office, on average, 3 customers are in line when the post office closes each day. The probability, P, that exactly n customers are in line when the post office closes can be modeled by the equation P equals 3 to the power of n times e to the power of negative 3 over n factorial. Given that e to the power of negative 3 is approximately 0.05, which of the following values is closest to the probability that exactly 2 customers are in line when the post office closes? All right, so N stands for the number of customers in line, and we're trying to figure out when 2 customers are in line. So we're going to plug 2 in for our N there, okay? So put a 2 in for the N, and then they also tell us that e to the negative 3 is approximately 0.05. Okay? So 3 squared is 9. Now you have this factorial. So a factorial, the way you calculate a factorial, I'll spell it for you. Factorial, right? Or you can remember it as factorial, and then you'll remember what that means. So a factorial, for example, if you were going to do 5 factorial, all you do is start with a number and then multiply it by the previous number and the previous number down to 1, okay? So like 6 factorial would be 6 times 5 times 4 times 3 times 2 times 1, right? 10 factorial would be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So that means 2 factorial is just 2 times 1. All right, it's not bad. Okay, so now let's multiply these top and bottom. So 9 times 0.05 gives us 0.45, and 2 times 1 is 2. So now divide the 0.45 by 2, and we get 0.225. So which one of our answer choices is the closest? That's D, 0.23. All right. Number 16. License plates on cars in a certain state consists of 3 letters taken from the 26 letters A through Z, followed by, and I can't believe I didn't fix this mistake. I'm so sorry, you guys. I missed a mistake. So on your worksheets, make sure that you fix this. It should say followed by 3 digits taken from the 10 digits 0 through 9. All right, sorry about that. Which of the following expression gives the number of distinct license plates that are possible given that repetition of both letters and digits is allowed? All right, so this is what we call a combination, okay? You're trying to figure out how many different combinations of license plates are possible, right? So we have something that is called the fundamental counting principle. Okay, the fundamental counting principle says that when you're calculating a combination, you take the number of ways that each event in the combination can occur and multiply them together. So in this case, we have 3 letters that we're choosing, and then 3 numbers that we're choosing. Ooh. So the fundamental counting principle says that all you do is take the number of ways that each of these can occur and multiply those together. And that's how many combinations are possible. Okay? So the license plate consists of letters taken from the 26 letters. All right? So that means you have 26 letters to choose from for your first letter. Now, here's something important. It says that repetition of both letters and digits is allowed. Okay, that means you have 26 letters the first time and you still have 26 for your second letter and 26 to choose from for your third letter. If repetition was not allowed, you'd have 26 to choose from for your first letter, but then only 25 for the second letter because the first letter would already be taken, right? And now we have numbers and we're selecting from 0 to 9, and it tells you right here, 10 digits, 0 through 9. 0 through 9 is 10 digits, okay? Be careful with this. A lot of kids mess up and put a 9 here because they think 0 through 9, but that's actually 10 choices. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You actually have 10 choices because of that 0. So you have 10 choices for each number, okay? So you have 26 times itself, 3 times. If we look over at the number choices, our answer choices, they're written in this format, and it's A. All right, next one. The table below shows the results of a survey of 250 people who were asked whether they like to read and whether they play a musical instrument. According to the results, what is the probability that the randomly selected person who surveyed likes to read, given that the person plays a musical instrument? So this given that the person plays a musical instrument tells us that we're only dealing with people in this column here that play a musical instrument. So now we want to know the probability that the person likes to read. So let's go here to like to read. And we see that we have 50 people like that in our column. And we find the probability by putting that in a fraction with the total. And we can reduce this, divide by 10, and we get 5/9. All right, next problem. The probability distribution of the discrete random variable x is shown in the table below. What is the expected value of x? So expected value, you want to be looking for these words, expected value. This has a formula, okay? So to find the expected value of x, the way we do this is you sum up. This little symbol here means sum. Each x times its probability. Okay? So that means we're going to take each x here, like 0, and multiply it by its probability. Right? 1, and multiply it by its probability. 2, and multiply it by its probability. And then what we're going to do, keep going, is we're going to sum them all. Okay? So we're going to add them all up. So we'll keep going. 3 times its probability. 4 times its probability. 5 times its probability. And 6 times its probability. Okay? So that's the formula. You sum up each x times its probability. All right, so 0 times a 6 is 0. 1/12. Let's not reduce any of the fractions yet. We'll just multiply them. Okay, now if I take a look at my answer choices that I've been given, the answer choices are all in fractions, so we need to keep working in fractions as we go. All right, in order to add fractions, you have to have a common denominator. So I see my fractions here have thirds, fourths, and twelfths. That means that 12 can be a common denominator. All right, so we have zeros, we can ignore the zeros. So let's change 2 fourths into twelfths. 4 times 3 is 12. So we need to multiply that fraction by 3 over 3 and get 6 twelfths. There's another 0, we can ignore it. And then 6 thirds, 3 times 4 is 12, so we can multiply this fraction by 4 over 4. Okay, so now we can add those all up and we get 38 twelfths. Okay, so 38 twelfths, we can reduce that. Right, 38 and 12 are both divisible by 2. So that gives me 19/6. Okay, so 6 times 3 is 18. So this is 3, 18/6, and we have 1 left over. 3 and 1/6 is choice E. All right. The 13-member math club needs to choose a student government representative. They decide that the representative who will be chosen at random cannot be any of the 3 officers of the club. What is the probability that Samara, who is a member of the club but not an officer, will be chosen? This is one to try on your own. You have 1 minute. And that's 1 minute. All right, and hopefully you're able to find that the answer is 1/10. All right, so how do we do this? There's a 13-member math club, but we're not going to include the 3 officers. That means there's 10 kids left to choose from. Samara is just 1 kid out of the 10, which means 1/10. Okay. At a school picnic, 1 junior and 1 senior will be selected to lead the activities. If there are 125 juniors and 100 seniors at the picnic, how many different 2-person combinations of 1 junior and 1 senior are possible? So again, we have a combinations problem, just like our license plate problem. So this time, what we're choosing is 1 junior and 1 senior. Remember, our fundamental counting principle says you count the number of ways that each one can occur and you multiply them. So we have 125 juniors to choose from and 100 seniors to choose from. Multiply that and you get 12,500, choice E. Okay, next problem. A certain hotel has 80 rooms. Based on many previous years' occupancy rates, the owners of the hotel constructed the table below, showing the daily occupancy rates and their probabilities of occurring for the coming summer season. Based on the probability distribution in the table, to the nearest whole number, what is the expected number of rooms that will be occupied on any day during the coming summer season? So your clue word here is expected. So remember our formula that we did before when we calculated our expected value. So this one here, what we're given is an occupancy rate and the probability. So if we calculate this, doing that sum of the occupancy rate times its probability, what we're going to get from that is the expected occupancy rate. Okay, now the problem asks us to get the expected number of rooms. Okay, so how do you get from the expected occupancy rate to the expected number of rooms? An occupancy rate is like a percentage that tells you what percent of rooms are occupied, right? So for example, in this first data, the occupancy rate of 0.60 means that 60% of the rooms are occupied. There are 80 rooms total. If you wanted to calculate the actual number of rooms, right, you would do the 60% times the 80 rooms to figure out how many rooms would be occupied, right? And that would be 48 rooms. Okay, so what we're going to do is we're going to calculate our expected occupancy rate and then multiply that by 80 rooms to get the expected number of rooms. Okay? Remember how to do this. We take our x value and multiply it by its probability, and then sum them all together, the sum of everything, all the products, right? I'm just leaving off the zeros because they take up too much room. Okay, so when you do this formula, what it gives you is the expected value of whatever your x is measuring, right? So we get an expected occupancy rate. Okay, so now we can multiply these together. 0.12, 0.28, just multiply all those on your calculator. And then add them all up and we get 0.73. So we have a 73% expected occupancy rate. So we're going to multiply that by the number of rooms to get the total number of expected rooms, and that's 58.4. But of course we're talking about whole hotel rooms, so we need to round in the nearest whole number, and that's 58. Next one. Let A and B be independent events. Denote P of A as the probability that event A will occur, and denote P of A and B as the probability that events A and B will both occur. Which of the following equations must be true? So this is just asking you what is the equation for calculating two probabilities with an and, right? And it's just an equation that you have to memorize, and the answer is choice D. You multiply the probabilities together. All right, so this symbol here is an and symbol, and if you see this one, that's an or symbol. All right, I remember the difference between the two because the and symbol sort of looks like the N in the word and, right? And that's how I remember. So just remember, if you're calculating the probability that more than one event will occur, and it's and, you multiply the probabilities. Next problem. Which of the following expressions gives the number of permutations of 15 objects taken 5 at a time? All right, so this one has a formula too. So now we're talking about permutations. We talked about combinations. So permutations is when you have a certain number of items and you're switching them all around. That's what permutations is. So like, if you had the word flower and you want to know how many different permutations of the letters in the word you could make, that's switching around the order, right? how many different ways can you switch around the order of the letters, right? And there's a whole bunch of different ways, okay? And then what we're doing here adds on another layer. It's permutations of 15 objects, and we're taking them 5 at a time. So it's sort of like if you're giving out candy and you have a basket with 15 candies in it, and you're telling the kids you can each take 5, right? It's 15 objects and you're taking 5 at a time, all right? So the formula for this, for n objects taken r at a time, is n factorial over n minus r factorial. So in this case, it would be d, 15 over 15 minus 5 factorial. Okay. Thomas and Janelle are playing darts in their garage using the board with the point values for each region below. The radius of the outside circle is 10 inches and each of the other circles has a radius 2 inches smaller than the next larger circle. All the circles have the same center. Thomas has only 1 dart left to throw and needs at least 30 points to win the game. Assuming that his last dart hits at a random point within a single region on the board, what is the % chance that Thomas will win the game? Okay, so let's label this with the information they've given us. They told us the radius of the outside circle is 10 inches. And then each of the other circles has a radius 2 inches smaller. So here's 8 and 6, 4, 2, right? Now he needs at least 30. Remember, the words at least and at most mean that the number is included. Okay, so at least means 30 is included along with 40 and 50. That's where he would have to hit to get at least 30 points inside that yellow circle there. Okay, so if we want to know the % chance, what's the % chance that he'll hit that yellow circle, we can take the area of the yellow circle and divide it by the area of the whole entire dartboard to figure out what % chance he has. So area of a circle, pi r squared. So the area of our little yellow circle there is pi times 6 squared, right? Because we labeled that radius there as 6 from the information they gave us. The area of the outside circle has a radius of a 10, so it's pi times 10 squared. 6 squared is 36, 10 squared is 100. We can cancel out the pi's from top and bottom, and we're left with 36 over 100, and that is 36%. All right. Machine A produces 500 springs a day. The number of defective springs produced by this machine each day is recorded for 60 days. Based on the distribution given below, what is the expected value of the number of defective springs produced by machine A in any single day? So here we have expected value again. So remember, if we multiplied this by its probability and summed it all together, we get the expected value of the number of defective springs. And that's what we're looking for too, the expected value of the number of defective springs. So all we have to do is calculate this and we don't have to do any other steps. Okay, so remember, it's the sum of the products. So we take our first value and times it by, times it by its probability and add it. Next value, keep doing that. Times it by its probability and add it. Next value times its probability. And then our final value times its probability. Okay? So multiply those in a calculator. And then add them all together, and we get 0.45, so it is choice B. All right, next one. Which of the following expressions gives the number of distinct permutations of the letters in people? So remember what we talked about, permutations is when you switch the letters around, right? Okay, now, but people has something interesting about it, okay? People has repeated letters. So there's 2 P's and there's 2 E's. I'm writing them in different colors, okay? So this means if you swapped the letter or the letters, right? Like let's say we swapped the P's. Okay, then technically I have swapped the P's. Technically that second word is a permutation of the first word, but it is not a distinct permutation because it makes the same word, right? So it is a permutation, but it's not a distinct permutation, okay? So usually when you do a permutation, right, people has 6 letters in it. So the permutation would be 6 factorial. Because if you think about, 6 letters here, and you have 6 letters to choose from in the word people. So if you're randomly switching them around, you can pick any one of those 6 letters for your first spot. And then let's say you picked E. Now you have 5 letters left over for your second spot. Let's say we picked L then. Now you have 4 letters left over to choose from. Pick another letter. Now we only have 3 letters left. Pick another one. Now we only have 2 letters left. And then we only have 1 letter left for our last choice. That is the definition of 6 factorial. So normally a permutation is just the number of items that you're switching around factorial. But in this case, we have some repeated letters here. We have the repeated P's and repeated E's. All right? So whenever you switch just the P's or switch just the E's, you're not getting distinct permutations. So what we have to do is divide out those permutations, okay? And you have two P's and you have 2 E's. So that's the way we do it. We divide out the factorial of how many of the repeating letters you have, okay? So let's say we'll just do like a nonsense word or something. Oh no, let's just pick a word. So like the word healthcare. All right, so in the word healthcare, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 letters. But what about repeats, right? I have 2 E's and I have 2 A's and I have 2 H's. So we'd have to divide out the 2 H's, the 2 E's, and the 2 A's in order to get the actual distinct permutations. All right? So hopefully that makes sense. Next one. For the first 5 possible values of x, the table below gives the probability, P of x, that a certain factoring machine will make x errors on any given workday. Which of the following values is closest to the probability that this machine will make at least 1 error on any given workday? So here's our word at least again. At least means that 1 is included, right? At least 1 means 1 or 2 or 3 or 4, and so on, more than what they gave us in this table. All right? In other words, it means any errors except for 0 errors at all, right? So the way we calculate this is you have to understand that the probability of every single possible event occurring is 100%, right? If we do an easier example, if you think about a dice, let me erase that. If you think about a dice has 6 sides, right? Let's say you have a dice like that. The probability of rolling a 1, 2, 3, 4, 5, or 6 is 100%. When you roll the dice, you're going to get one of those numbers, right? the probability of everything happening is 100%. So if we want to know everything but 1, the probability of everything happening except for 0 probability, or 0 errors, we can take 100% in decimal form, that's the whole number 1, and subtract out the probability of 0 errors happening. And what's left over is everything but 0, right? That's what we just calculated. We're going to calculate everything but 0. So you subtract that and you get 0.9177. Choice E. Okay. Next one. A wallet containing 2 $5 bills, 9 $10 bills, and 5 $20 bills is found and returned to its owner. The wallet's owner will reward the finder with 1 bill drawn randomly from the wallet. What is the probability that the bill drawn will be a $20 bill? Here's your next one to try on your own. 1 minute. Go ahead. And that's 1 minute. Now hopefully you're able to get the answer is D, 5/16. So we want the probability that the bill will be a $20 bill. There are 5 $20 bills to choose from. And if we add up 2 5s plus 9 10s and 5 20s, we know that there are 16 total bills, 5/16. Okay, in his costume supplies, Elmo the clown has 4 noses, 3 pairs of lips, and 2 wigs. A clown costume consists of 1 nose, 1 pair of lips, and 1 wig. How many different clown costumes can Elmo make? So we're doing a combination problem again. How many combinations of a nose, lips, and wig can he make? So we're going to use our fundamental counting principle again. We're going to pick a nose, lips, and a wig, and we're going to multiply the number of choices. So we have 4 choices for the noses, 3 for the lips, and 2 for the wigs. Multiply them together and we get 24. All right. Next problem. A bag contains 16 red marbles, 7 yellow marbles, and 19 green marbles. How many additional red marbles must be added to the 42 marbles already in the bag so that the probability of randomly drawing a red marble is 3/5? All right. So the probability of drawing a red marble with the number that we have right now is 16 red marbles out of 42. We want to know how many should we add in order to get 3/5. Now here's the tricky part. If we add X number of marbles to our red marbles, you also added that many to the whole bag itself, right? If I add 5 more marbles in, then my total is no longer 42, it's 42 plus 5, okay? So you have to make sure that you add on to both. And now we're going to cross multiply. And remember up here from our algebra lesson, these are binomials that we're multiplying by. So you have to make sure that you write it with the parentheses here so you can distribute. The 5 has to distribute to both terms. Okay? So we get 80 plus 5x equals 126 plus 3x. Okay? Now we need to get our x's all together and on one side. So let's subtract 3x off both sides. And then subtract 80 off both sides. And then to get the x all by itself, we can divide off that 2, and we get that x equals 23. Okay, now we have another one where we have information, and we're using it to answer multiple problems. The Harrisburg Recreation Center recently changed its hours to open 1 hour later and close 3 hours later than it had previously. Residents of Harrisburg age 16 or older were given a survey, and 560 residents replied. The survey asked each resident his or her student status, high school, college, or non-student, and what he or she thought about the change in hours, approve, disapprove, or no opinion. The results are summarized in the table below. So question 31 asks, suppose a person will be chosen at random from these 560 residents. Which of the following values is closest to the probability that the person chosen will not be a high school student and will not have replied with no opinion? All right, so not high school student. What does that mean? That means everything but high school student. That means college and non-student. Next, not replying with no opinion. That means everything but no opinion. That means approve and disapprove. So where our lines intersect, that's what we're looking at. These 4 little values there. Okay? So 14, 10, 85, and 353 out of the total 560 residents. Okay, so we add this up and we get 462. Our answer choices are in the form of decimals, so we're just going to divide that and get our decimal. And then which one is that closest to? Choice D. All right. So same information. And this one is another one where it's very time consuming to do. Remember, one of your strategies should be time management. And if you start working on a problem and it is obviously taking a very long time, it's a good idea to put it on hold, right? Put a circle around that problem, fold down the edge of the paper to mark the spot, and then just keep going. If you end up with extra time at the end, you can go back and solve those time-consuming ones. If you have very little time, you can go back and mark a guess answer for those ones, right? Remember that you only have 60 minutes to answer the 60 questions, an average of 1 minute per question. Okay, so be on the lookout. Don't get sucked into very time-consuming problems. So let's look at this one and we'll see why it's a time-consuming problem. So it says, it's discovered that the student status of 15 residents who replied that they had approved have been incorrectly classified as non-students. After correcting the errors, exactly 60% of the college students had replied that they approved. What percent of high school students replied that they approved? All right. So we know that there are 15 residents that aren't actually non-students. They're actually either high school or college. So in other words, the incorrectly classified high school plus college students add up to 15. And we know that 60% of the college students, once they added those in, replied that they approved. So if we do the 14 college students who did approve, plus the college students that were incorrectly classified, that is 60% of the total college students. So total college students is 14 plus 10 plus 6 plus the number that were incorrectly classified, just like our red marbles problem. If you add a certain number of red marbles to the bag, it adds to the total of the bag as well. So we have to add that C into both places. Okay? So 14 plus 10 plus 6 plus C That is 30 plus C. Right? And then we can distribute this 0.6. And then we can solve for C. So we need to put the C's together. I'm going to move down here now. So 1C minus 0.6C leaves 0.04C. And then move the 14. And then divide by 0.4. Oh, not C, just 0.4. Sorry about that. Okay. And then 4 divided by 0.4 tells us that there were 10 college students misclassified. So if we go back up here to the top, remember we're trying to find percent of high school students. The high school plus college that were misclassified together was 15 total. So if our college students were 10, now we know that there were 5 misclassified high school students. So now we need to figure out, take this value and add it into the high school students. Okay, so we now also have this plus 5 misclassified. Well, it goes here because they approved. We have plus 5 that approved that were misclassified. So now instead of 30 approving, we have 35 that approved out of 35 plus 4 plus 11. Okay, so that makes 35 out of 50. And if we divide that, you get 0.70 or 70%. Okay, so this was a time-consuming problem. And watch out for those. Don't get sucked in. Okay. A professional baseball team will play 1 game Saturday and 1 game Sunday. A sports writer estimates that the team has a 60% chance of winning on Saturday, but only a 35% chance of winning on Sunday. Using the sports writer's estimates, what is the probability that the team will lose both games? Remember, if you have all the possibilities, right, this is like a flip a coin one. You can either win or lose. There's only 2 probabilities. And if we want to figure out lose, we need the probability of losing here. Okay? How do we calculate that, right? So there's a 100% chance that they will either win or lose. Remember that from before. You have a 100% chance of every probability occurring. So if we take our 100% chance and subtract out the 60% chance of winning on Saturday, that leaves us with a 40% chance of losing. Do the same thing for our Sunday, and we get a 65% chance of losing on Sunday. And then remember our formula that we learned for finding an and probability, the probability of losing on Saturday and losing on Sunday. That was this thing. And to figure that out, you multiply the probabilities. So we multiply the probability of losing on Saturday by the probability of losing on Sunday. Whenever you're multiplying or doing anything with percents, you need to change them into decimals. That's very important. Okay? Multiply those 2 numbers in a calculator, you get 0.26, which is 26%. And here we are on our final problem. Get a Great Read Books is adding a new phone line. The phone company says that the first 5 digits of first 3 digits of the phone number must be 555, but the remaining 4 digits where each digit is a digit from 0 to 9 can be chosen by Get a Great Read Books. How many phone numbers are possible? So in other words, their phone number is going to be this, and we're doing a combination of the other 4 numbers, okay? So this is one to try on your own, digits 0 through 9. Go ahead. And that's 1 minute. Hopefully you're able to get that the answer is E, 10 to the 4th. Remember that 0 through 9 is actually 10 digits to choose from. The 555 part is fixed. So you're not actually doing any combination with that at all. So any of these that have 5 in the beginning, that's trying to fool you. Okay? And then the 9 to the 4th is counting on kids that are thinking 0 through 9 is only 9 digits. Remember, 0 through 9 is actually 10 digits. So you have 10 to the 4th to choose from. Okay, and that is the end of our practice problems. So now it's time to reflect metacognitively. Assess what strategies did you learn for solving statistics and probability problems. Evaluate which problems were easy and which were hard. What are your strengths and your weaknesses when it comes to statistics and probability? And then make a plan. What will be your plan of attack for statistics and probability problems on the ACT test? Okay, and then remember the last steps. Now that you've taken the whole course, during the test, apply your strategies and monitor your performance so that you can reflect and adjust as needed during the test. Thank you for taking the course. It's very important to get on there and take that post-test, right? That gives you extra practice and you'll be able to see your improvement from the pre-test. Practicing is key in mathematics. I always say the difference between knowledge and being able to apply knowledge is practice. So be sure and do that practice test, and I hope you have good luck on your ACT test.